This week we're going to compare dichotomous outcomes between a group after adjusting for a few other potential nuisance variables. So rather than using simple logistic regression like last week, in this case we're going to use multiple logistic regression to try to adjust for a bunch of variables we may or may not care about, and then compare the adjusted risk between two groups. So to do this, we're going to have to start off with a little bit of data, and so we'll go to the example data for this week. So here, this is the expanded data for the indomethacin study that we looked at last week. So I'll just grab all of this, copy it to my clipboard. I'm going to put this into SPSS. So you'll notice now we still have group, we have outcome, but now we have a whole bunch of other variables that might matter. Age, gender, right? All kinds of things, whether they're taking aspirin or not. There's a lot of risk factors here that could influence the risk of pancreatitis, which is our outcome. All right, so just like last week, we're going to head on over into SPSS, and we'll paste in our data with the variable names, and this will think for a little while. And there we have it. We could rename these so that we remember what they are. For example, the group in this case, we could change our values over here. The value 0 would be our placebo. 1 is indomethacin. And our outcome here, in this case 0 is the good thing. Here we have no pancreatitis. And 1 we have pancreatitis, which we'll just call pink. That's fine. Okay, but we're still 1s and 0s. Here's just change what it looks like. All right. So what we want to do now is analyze regression, and we'll go to binary logistic. In other words, we have two possible outcomes. It's binary. That's what that means there. All right, fairly straightforward here. In the dependent, we're going to put our outcome, which in this case is called outcome. And then we can add in our other predictor variables. So last week what we did effectively was just run group all on its own. So I'll run that here as its own block so we can get that for comparison's sake. But what I really care about is taking group and all the rest of those variables and sticking those into the equation. So now I have two blocks. One is my unadjusted risk comparison for pancreatitis between the two groups, and the other is going to give me my adjusted risk comparison. In categorical, you can go in, you can specify the different categorical covariates to say who you want to compare in case you're doing some further comparisons here. We don't really need to do anything, but I'll put in group here because that's the one that I care about. If we're making some kind of predictive model, we definitely want to see what it's predicting. We'd want to save the probabilities and group membership. That's not what we're doing here, so I don't really care about those. I'll leave them unselected. But if we were making a predictive model, we'd want to compare our predicted group membership across the actual group membership to see how well the model works. Not what I care about, so we're not going to do that. Under options here, we definitely want to make sure we have the confidence interval for my XB. Okay, what this means, X, we're exponentiating. B would be the regression coefficient. In other words, XB is the odds ratio. We could care about goodness of fit. Always good to look at that to see, hey, how perfect are your predictions? Again, we're not using a regression to predict anything here. We're using it to adjust for variables that we don't care about, but a reviewer might bicker about later. So I will leave this unchecked, but you could check it. Only if you're trying to make predictions. Okay, at this point we're good to go. We can click OK. And we get our output. Now some of this we don't care about. This beginning, okay, this doesn't really matter. This is just telling me what things are coded as. Doesn't matter to me. Now you'll notice here we have 1, 2, 3 blocks. Block 0 This is showing me my regression coefficient with nothing in it. I don't care about this. This means nothing. Block 1, here I am. This is my unadjusted odds ratio right here. I get 0.494, ranging from about 0.3 to about 0.8. So in other words, there's lower odds of pancreatitis if I am given indomethacin. Excellent. We saw that last week. Now what we get down here, block 2, notice we've got a lot more variables in our model. But what I care about here is this adjusted odds ratio. Now, odds ratios are great for statistical software, not really great for us to interpret. So I'd like to get this into an adjusted relative risk, risk difference, and even a number needed to treat. Unfortunately, or maybe fortunately, there's no good way of doing this in SPSS. So what we're going to do here is not work in SPSS. So I've made a little tool here that'll allow you to get those statistics once we know just a few things from SPSS. So we'll head on over, and this is our simple risk calculator. Now we used this one last week. I've added a new calculator for you to allow you to get adjusted relative risks and risk differences. Okay, so we need to know the size of the experimental group. In other words, how many people were given indomethacin. Okay, well that's pretty simple. Let me go back to my data and let's analyze descriptive statistics, cross tabs. So in the groups, let's get my outcomes. Now I could go in, get my risk, chi-squared. I don't care about that, so I won't. I really just want this right here, the crosstabs. So there were 295 folks in the experimental group and 307 in the placebo. Fill those in. Now I want to know, how often do people get pancreatitis in the placebo group, in the control group? Well, we can see here that 52 folks did. So I'll just tell it this is equal to 52 divided by the number of people, right? That information up here in D5. And that gives me about a 16.94% event rate. And it fills out my 2x2 table for me over here. Now I just need my adjusted odds ratio, and for that I scroll on up to this variables in the equation. I look for group. I don't want the coefficient, I want it exponentiated, and there we go, 0.411. And from here, we're going to do some pretty basic math. You can check out the formulas there if you care. And we get now an adjusted odds ratio that matches, of course, but more importantly, we get the adjusted relative risk, the adjusted risk difference, and the adjusted number needed to treat. For comparison, let's fill out this table using the actual numbers. So in this case, it'll be the same for the control group, 52, 255, and then we have 27 and 268 for the indomethacin group. And you'll notice these are a little bit different. My relative risk was 0.54, but after adjusting for all those other covariates, it's dropped down to 0.46. Very similar, but a little bit different. And that's all we have to do to get our adjusted relative risk, risk difference, and number needed to treat. Pretty straightforward stuff. If anything is confusing to you, make sure you let me know one way or the other, either by email or in the questions box. Hopefully everything makes good sense and you're able to tackle the checkpoint questions. If not, let me know. I'm here to help.